What is a number theory? Number theory is a branch of a math that deal with properties and relationships of numbers, especially the positive integers. So the focus is on the positive integers. So when we talk about numbers, there are quite a lot of numbers. I assume everyone knows those definitions. What are the natural numbers? Counting numbers, whole number, positive number, negative integers, and non-negative integers, then the integer that including all of those. Natural numbers and counting numbers are the same. We are only talking about 1, 2, 3, 4, 5. So 0 is not a natural number. 0 is not a counting number. But when we talk about whole number, then we need to include 0. So 0 and natural number, they consist of a whole number. Then positive numbers, same as a natural number and counting numbers. And negative numbers, they're just the opposite of positive number. Then is 0, when we want to include 0 in the integers plus the positive, then we talk about a non-negative number. If we want to include 0 and negative number, then you say non-positive numbers. Okay. So this diagram, then beyond the integers, right? We start from a natural number, counting number is a small section. Then we include in 0. Then it's a whole number. Then include a negative number, then it consists of all integers. So that's what number theory focuses. Number theory is focused on the integer, but especially the thing focusing on the whole numbers and the non-negative part. Then beyond integer, you have rational number. Right? Rational number is a number that can be expressed as a fraction of 2 integers. Then you have irrational number, like root 2 or pi or the e. Then the irrational number and rational number, they consist of real number. Then those imaginary number, there's plus the real number, they call it a complex number. I assume everyone knows those definitions. So we can move on to some of those actual definition. Beyond those numbers definition, there's also called the perfect square. A perfect square is an integer equal to the second power of the number. There's a perfect cube, and then you can even beyond that, you can extend the definition, so perfect power. Okay.
Somebody emailed me, asked for the class link, but it's 10 minutes ago. Just check it, everybody.
Oh, okay. So somebody is asking the email. No?
Class link.
So we just send out this last link in the email. Just reply in it's your copy. Just reply in the email. So Andy just back, but he didn't prepare the class. He want me to continue the class. Okay, let me just make sure that there's nobody waiting in the waiting room. I think everyone is here. Okay. Okay. So within integers, so we can subdivide some of the numbers. There's odd numbers, even number, and square. So we talk about those cubes. Then prime numbers. Prime numbers versus composite numbers. Then there is a modulo. So this is something probably a little more advanced. Modulo, I think we're going to talk about the modulo later. Then there's modulo is looking at the remainder. So it's a modulo 4. That means 1 modulo 4. That means any number divided by 4 that has a remainder of 1. So 1, 5, 9, they're all numbers that when you divide it by 4 has a remainder of 1. So modulo 4, 3, that means any number divided by 4 has a remainder of 3. Right. Triangular numbers. So let me ask a question, see whether anyone knows what's the definition of a triangular number. How do I get to? Okay. Okay, now everyone can talk. So does everyone know the definition of triangular numbers? Hello?
We don't know.
You don't know?
Hi. Not really.
Okay. So triangular numbers are those numbers that you do the continuous summation of number from 1. So 1, 2, you sum of 1, 2, then equal to 3. So the first number is 3. Then the next number, 1 plus 2 plus 3 plus 4 is 7. The next one. Then you keep adding the next number. 7 plus 5 is 11, etc. So you're adding. So why it's called triangular? If you put those numbers that you're adding, right, it is like this shape. So the first 3 numbers you put them together is a triangle. Then you're adding the next row. So you're adding 3 more numbers. So it's 6 like this. So that's why it's called triangular number. So you're adding 1 more row. So you put it in a pie, it's a triangular shape. That's why it's called triangular number. Does it make sense?
Yeah.
So perfect numbers. So this is something I think we're going to talk about later on. Perfect number is a number equal to the sum of all its positive divisors. Okay. So 6 has the 3 divisors, 1, 2, and 3. So you add all of them together. So the sum of all the divisor is also 6. That's why 6 is called a perfect number.
Wait, let me listen to.
No.
Okay. So the next perfect number is 28 because when you factor 28, there's 28 the positive divisor is 1, 2, 4, 7, and 14. You add them all together, is 28 equal to itself. So 28 is a perfect number. So those are concepts we're going to talk about it, in the future. But those are some of the numbers within the integers. There's also an interesting number called Fibonacci number series. So does anyone know Fibonacci's numbers?
Yes.
Yes. So can anyone give me a definition of Fibonacci numbers?
The number is the sum of the 2 numbers before it.
Okay, that's very good. So you start from 1. So 1, so plus the number before is 0 is 1. Then 1 plus 1 is 2. Then the next number is 1 plus 2 is 3. Then 2 plus 3 is 5. 3 plus 5 is 8. Then 5 plus 8 is 13, etc. So Fibonacci number. Okay. So all of those about the number theory, they call it a theory, so looks very intuitive, right? So why still have people, professor, they still study number theory? Why it looks so simple? Why does still people do research and study in number theory? So has anyone heard about this Goldbach conjecture? So you can talk, so everyone I think is still
No.
unmuted. No? Okay, so for those of you that understand Chinese, so the Chinese translation is called 哥德巴赫猜想. So go ask your parent what is 哥德巴赫猜想. So all of those can understand Chinese, ask your parent that. I think all of your parents have heard of that. 哥德巴赫猜想. So it is a very famous conjecture. It is what is it called conjecture? Conjecture is a thinking or a theory is unproven the theory, then it's called conjecture. So nobody can prove the theory yet, but nobody can unprove the theory is not true. So that's why it's called conjecture. So either prove it is wrong or prove it is correct. So, but nobody can do either of them. So that's why it's remain a conjecture. So there's a Goldbach conjecture, which is proposed by more than 200 years ago by the mathematician Goldbach. It said every even integer that is greater than 2 is the sum of 2 prime numbers, right? So we can verify this is true for all of those numbers. You can name them, you can verify them. 4 is 2 plus 2, 6 is 3 plus 3, 8. So it's list all the even number you know. You can always find 2 prime number consists of 2 prime number. So we can verify all those known even number. This theory is true, but we just cannot prove this is true for all even numbers that is greater than 2. So that's why it is remain a conjecture. So there is you can visualize this conjecture. So for all the even number that greater than 2, you list it. Then you draw the diagram. What are those prime number that you can add to this even number? So this diagram, like the intersections, are those prime number that can add up to this even number. For example, let's say 20. So 20, there are actually 2 solutions. 20 can be 13 and 7. Or you can come up here, 17 and 3. So there are 2 solutions for 20. So you can either do 13 and 7 or 17 and 3. So same for 22, there are actually 3 solutions. So 11 and 11. Or you can do 5 and 17, or 19 and 3, etc. So for all the known even number, you can always find at least 1 solution. That even number can be the sum of 2 prime numbers. But nobody can prove this is true for all the even numbers that are greater than 2. So nobody can prove that. So maybe in the future, this is something that interests you. If you prove that, I think there is a huge amount of money involved if someone can prove this theory is true. So number theory is a lot of conjecture like this. It looks very simple, but it's so hard to prove it. So that's why there's still a lot of people study a number theory. Okay. So there's we divide the numbers within the integer as a primes and composites, right? So a prime number is just a natural number whose only positive divisors are 1 and itself. Then composite is just a non-prime number. So that means we can find a positive divisor other than 1 and itself. So let's do a problem. So does everyone know what are the prime numbers under 100? So you can talk. I think everyone's still unmuted. And how many prime numbers under 100? Can anyone shout out? How many prime numbers under 100? Okay. If you don't remember, let's do an exercise. So those are the numbers under 100. We don't need to list 1, right? Because 1 is not a prime number. So prime number 1, when we talk about prime number, 1 is not a prime number. It's not a composite number either. 1 is just a special number. Right?
It's just an integer?
It is just an integer. It is a natural number, it's a counting number, it's an integer, but it's not a prime number, it's not a composite number. Okay. So we start with 2, from 2 to 100. So how do we find out the prime number? Right? So you can first cross out all the even numbers other than 2, right? Even number, they can be divided by 2, so they are not prime numbers. So we can do like this, cross out all the even numbers other than 2. So only have the column under 1, and then column under 2 only 2, then the column under 3, 5, 7, and 9. Then the next step, you can cross out all the 5 other than 5 itself, right? They all divisible by 5. So we can cross out this column by 5. Then you can cross out the multiple of 3. So how do you identify the multiple of 3? So multiple of 3 in the 1 column, so 21, then you skip 2 number, the next one, right? So 21, then 51, 81. Those are the numbers divided by 3. Then under the 3 column, 33, then you skip 2 number, 63 and 93. Then under the 7, 27, you skip 2 number, 57, 77. And no, 87. 77 is divisible by 7, which we will do next chapter. Under the 9 column, so 9 is divisible. So you skip 2 number, 39, 69, and 99. Then the next, you need to cross out the multiple 7. Multiple 7, so under, so other than those we have already crossed out, those are divided by the 3. So the only 49, 77, and 91. So after we done cross out, then all the number remaining are prime numbers. And we need to cross out the thing 11. So the one, the 11, the multiple 11, we don't need to cross out multiple 11. This multiple 11 under 100 should be already crossed out. Do you know why? Can anyone answer the question? Why do we don't need to care about the multiple of 11?
Because
Okay, can. So 11, if a multiple 11 under 100, that means you can only multiply by 7, 5, 3, or 2. If it's a multiple by 11, it's 11 times 11 is greater than 100, right? So we don't need to care about 11 times 11, 121 is beyond this, so we don't need to care about that. Okay, so how many prime numbers under 100? How many of them remaining?
25?
Yes. So I think everyone, there's a lot of people still muted. I unmuted everyone.
Yeah.
I don't know why. So they
okay. Muted themselves, that's why.
Oh, okay, they mute themselves. Yeah. Okay. So we are doing exercise. We need everyone's participation, right? But do not write it on the board. Please, whoever is doing the annotation, stop it. Okay. Okay. So I'm going to.
There's only 10 minutes left.
Yeah.
Facts.
So if with this video, this Zoom meeting start, they need to just take a break and then log back in using the same link. Okay. So those are the 25 prime numbers under 100. How do I create? Please, okay, do not draw on the board. Okay, now we need everyone to do this problem. Find all the positive divisors of 20, and then find all the positive divisors of 30. Then find out what are the positive integers that divide both 30 and 20. Okay, so do that on your paper. So I need everyone to do this exercise. Okay, let's do this. You do this exercise. I'm going to end this meeting since I think we only have a few minutes left. Then we'll resume in 5 minutes when you have your answer. Okay, need everyone to rejoin back in 5 minutes. So we'll join it at 11.